here we are solving missing number problem. So the problem statement says that we are given an array and that contains distinct numbers in the range from 0 to n, and we have to return that missing number which is not part of the array. Let's see some examples. So the first example says that we have array with values 3, 0 and 1, and out of here 2 is missing, and that is what we have to return, right? In the next example we have two elements 0 and 1 and 2 is missing, right? In the next we have 9, 6, 4, 2, 3, 5, 7, 0, 1. Here 8 is missing. This is what we have to return. Okay, so the range of the elements from where we have to match is from 0 towards the array length. So here if you see, the array length was 2. So 0, 1 and 2. Out of this 2 is missing. 0, 1, 2, 3, 2 is missing. So that's what we are returning. Got it? Also have a look over the constraints. There are 4 important things. One is the n, the range, which is equals to the length of the numbers array. Okay. Next, there will always be at least one element present, and in the next, the range, the elements of the array will be from 0 to n, and all the numbers will always be unique. So the most straightforward approach that I can think of is, first we will be taking a outer loop, and that outer loop will be running from 0 to n, to this range, and in the inner loop we will be checking if any value from the outer loop, if that is not present inside the inner loop. The inner loop will be running from 0 to array length. So if any value from 0 to n, if it is not present in array, so then that is our answer and we can return that. Okay. So if you will be presenting this approach to your interviewer, the interviewer will definitely ask you to optimize, because you will be consuming order of n square, and there are more better ways to achieve a solution for this problem. Here comes our next approach. So in the next approach, we will be calculating the sum of 0 to n. Once we have the sum from 0 to n, so then we will also be calculating the sum for this array. And once we have the sum for both the arrays, we will be subtracting the sum. Based on that, we will be getting our answer. Okay, let's code. Also stay tuned towards the end of this video, as we will be also discussing a ES6 way to solve this problem. So let's dive deep into the code. So as discussed, approach 1. In the approach 1, we had the idea of creating two nested loops. So in the first loop, the outer loop, we will be ranging from 0 to the entire nums length. Okay, equals to nums.length. And now we will be creating a flag. This flag will be to track the value whether it is found or not. So if we found any value which is equals to the outer loop, so in that case we'll mark the flag as 1, and if we don't found any value, in that case we will be returning that element. Okay, so let's see. Now we will be looping from to the length, and here we will be actually checking if my nums of j, if that j is equals to my I. So in this case, that means I found the element which I am looking for. So in this case, I can simply mark my flag to be as 1, that hey, you don't need to worry about this iteration because this element is already present, and I can simply break. And once I am outside of my this inner loop, so in this case I can check here if my flag is 0. That means if for any I value, if that match was not found, that means the flag would have been 0 only. So in this case, I can return my I, and I am confirmed that okay, this I value is not present in the array item, right? Since this is expecting a number in return, we need to return -1 because this will give us error. Reason being, it's expecting a value in return, right? So let's also return that. Although for this constraints, it will not be applicable, though we are still returning it. Okay, so custom input passes. Now let's submit it. Okay, cool. Now let's move on to the next approach. Let me just comment this. Now moving on to the approach 2. So in the approach 2, as discussed, we will be calculating the sum. So there are two methods. If you have heard about Gauss theorem, so the Gauss theorem says that the sum of 0 to n can be calculated with a formula which is n into n plus 1 by 2. So this is a short formula with which we can calculate. So I'll be showing both the ways. So one way is we actually calculate the sum. So okay, in that way we'll declare the sum which is the expected sum, and let me declare it as a let expected sum is equals to 0 and current sum, which is the array sum, is equals to also 0. So first we'll loop from I lesser than equals to nums dot length and I plus plus. So here we'll simply say let's do expected sum plus equals to I. So this will be our expected sum, and now we'll calculate our array sum. Right? So our current sum, which is the array sum, you could have named it array also, array sum also. So array sum equals to nums of I, right? So with this we will be having the current and the expected sum. So we can simply return our expected sum minus the current sum, right? So let's test this. Cool. And now let's submit this. Okay, so now showing you the next approach. Here, instead of this entire loop, we can simply say our expected sum to be equals to nums dot length into nums dot length plus 1, and this entire thing divided by 2. So this will be our expected sum. Let's check the custom input. Okay, so if you see, it's passing the input test cases as well, and when we will be submitting it, so this is another way. So here if you see, this is a order 1 operation, and this is much better than this entire thing because we are consuming a lot of time here, and this is just an order of 1 operation. Let me just also write this, that this is some second way. Okay, so as promised, let's move on to the ES6 way of solving this problem. So the first thing that I have to do is, let's first write ES6 way. Okay, so the first thing that we have to do is we have to calculate the expected sum. So for ease, I'll actually do this in the same line only, in the declaration only. So I'll just copy this formula. Okay, so now we have the value from this formula, and post this, now we will be creating our current sum. So the current sum will be coming through the reducer. So if you remember the previous videos, there we discussed that the reducer requires two mandatory things. One is callback function and another one is the current value. So let me just write it, nums dot reduce, and what we will be doing is we will be calling the callback function. This is the callback function and the initial value. Okay, and now the two important parameters for the callback functions are, one is the accumulator and next one is the current value, right? So we can simply say that my accumulator, which will be storing the result, is equals to my current. So this is what we can simply return out of here. This is it. Once this is done, we can simply return our expected sum minus the current sum. Got it? So let's test this. Okay, so the input test cases are passing. Great. So we were able to solve this problem via 3 approaches, and let's analyze the time and space complexity. So the time complexity for the first approach, which is this one. So if you see, for obvious reason, we have 2 loops. It is order of n square. So the time complexity is order of n square, right? Okay. The next one, which is the space complexity. So the space complexity for this one. Okay. So we are declaring this flag, nothing else, right? So the space complexity also will be order of 1. Okay, for the approach 2, let's calculate the time complexity. Okay, the time complexity for this one is, in the first approach where we are calculating the sum through the for loop, it's order of n plus order of n. So it would be big O of n only. Okay, and if we use the second way, it will be order of 1 and order of n. So again, the time complexity will be order of n. If you ask me, this is a better approach. If you want to give your interviewer a solution in the first go, so this would be a better solution. Okay, space complexity would be order of 1 only. So here, if you see, we just are creating two variables and nothing other than that. So again, space complexity will be order of 1. Okay. In the last ES6 way, here again we are doing order 1 operation in terms of time, and we are doing a nums.reduce, which will be again a order of n for this entire array. Got it? The time complexity for this as well is order of n. And what about the space? So the space, as discussed, the reduce doesn't takes any memory, so it will be order of 1 only. So if you ask me, if you are giving this solution in a front-end interview, this is much better solution, a 3-line code, right? So that's all for this video. Thank you.